Armatures, or skeletons, can be very powerful, but they can also get very messy. If you have a very complex rig with different deformed bones, controllers, constraint-specific bones, etc., you'll want to start hiding certain bones or selectively viewing others so that you only see the bones you need at any given moment. This is where bone layers come into play. Instead of manually hiding and unhiding bones as you work, you can actually place bones in certain bone layers within your armature, allowing you to selectively view any given bone layer or layers at any time. This works differently from collections as there is a maximum of 32 layers, but oftentimes that is more than enough. I'm going to demonstrate bone layers on a simple rig, but just remember bone layers are most often used on complex rigs where organization is necessary for clarity. We can see the bone layers visually in the Armature Properties tab in our Properties editor. This tab is indicated by a green stick figure icon. Once there, you can see this horizontal grid-like pattern which represents our bone layers. You don't have to count them, but there are 32 squares displayed here horizontally. The other 32 squares you see right below the layer section is for selecting which layers from above will be considered protected layers. They're technically still referencing the same 32 layers we see up here, but we'll come back to this section later. Clicking on a square in the grid will enable that layer exclusively, hiding all bones on all other bone layers. Holding Shift and left-clicking on another square will allow you to toggle on or off multiple bone layers at a time. You might notice that the first square here has a small white dot in the middle. This represents the fact that there are bones within that layer, and typically, enabling that layer will make these bones visible. By default, our bones exist on our first layer, and our first layer is already enabled. Now that you understand that, let's get to organizing. You can choose to organize your bones however you want, but let's say for our sake, we want to simply move our bones of each limb in our rig to separate layers, while still keeping the rest of the rig in the first default layer. So to accomplish this, we'll need 5 layers total, including our first layer. Let's choose 5 layers that'll make sense visually in our bone layers grid pattern. I'm going to choose these 2 for our left and right arm bones, and these 2 for our left and right leg bones. This way, I know that the top layer is generally for left-hand side bones, and the bottom layer is for right-hand side bones. Now let's move our bones where they need to go. I'm going to start with the left arm bones. To move our bones to a different bone layer, simply go into Pose mode, select the bones you want to move, and go to the Pose menu at the top left of our viewport. You can then select Change Bone Layer. This will pop up a menu that looks exactly like our layer grid that we saw in our Properties editor. For hotkey users, simply hover over anywhere in the viewport and press the M key as in Move to bring up the same layer menu. Now you can simply select the layer or layers you would like your selected bones to reside in. For the left arm bones, we decided to place them here in the second layer of the top row. Once we do that, you can see that our bones have disappeared from our viewport as they are now hidden in the second bone layer, while we still only have the first bone layer enabled. Let's repeat this process for our other limbs. Now that we have our bones in the right layers, we can select these layers with left-click to see each limb's bones independently, or shift-select to enable multiple bone layers at a time. You may have already noticed that only one square in the grid pattern actually has a filled white dot, while the others have a hollow white dot. The filled-in white dot simply indicates which layer your last selected bone, or active bone, is on, while the hollow white dots simply indicate that there are bones present in that layer. And those are the basics of bone layers, but we haven't touched on what this protected layers section does exactly. For most beginners, you probably won't have to touch these settings, as they refer specifically to when the rig is imported into other Blender files and referenced as a proxy. Protecting a layer tells proxy rigs of this source that bones on that layer should prioritize and reference the original data from the source file if the source changes. Referencing files is most common in studio environments or group productions. And those are the fundamentals for bone layers, but for further organization, I also recommend bone groups. What are bone groups? Well, let me just show you real quick. Bone groups can be edited right below the bone layers in the armature properties of our properties editor. Expand that and you'll see a very familiar interface if you've worked with vertex groups already. To create a new bone group, simply press the plus key. Double left-clicking a group will allow you to rename the group to whatever you want. I'm going to call this left. And now, since you probably know what I'm going to do, let's create another group called right. We can add bones to whatever group we have selected in this list by simply going into pose mode, selecting what bones we want, and clicking the Assign button in the Bone Groups interface in our armature properties. I'm going to go ahead and organize these bones so that the left-hand side bones are assigned to the left group and the right-hand side bones are assigned to the right group. Okay, now that I've done that, let's go ahead and deselect everything with Alt-A. Now what's great about bone groups is that we can very easily select or deselect bones in that group by selecting the group in that list and clicking the Select or Deselect buttons here. But another great benefit of bone groups is colors for visual clarity. What I love to do, for example, is to mark our left-hand side bones as red and our right-hand side bones as blue. How do we do this? Well, you can simply select our left group and go to the color drop-down below. From this, we can select a color set that matches what we want, or we can create a custom color set. When setting custom colors, you can read more about what each color is used for by hovering over each colored rectangle. Let's do the same thing for the right group. Now we have this very colorful rig that helps us and whoever animates with this rig understand at a glance which bones belong to which groups. Important note, unlike vertex groups, bones can only belong to one bone group at a time. I hope you find these tools useful for understanding and organizing the bones within your rigs. Keyframes are the foundation of animation. Even if you aren't familiar with animation, you've probably still heard of the word frames, as in frames per second. Frames are basically just still images, and the number of frames per second is how many still images are shown sequentially on screen per second. A sequence of frames creates a moving image. Keyframes are the most important, or key, frames in a moving image. And for an animation, these are set manually by a human animator. The keyframes are typically where the key poses of your characters lie. In other words, if someone was doing a run cycle, the keyframes would be most likely at the extreme points of the run cycle, as well as some important transitions between how the legs move relative to the rest of the body. So what do keyframes do for animation? Well, in digital animation, if you mark the key poses, the software can often interpolate or blend the frames in between so that you get a smooth movement between keyframes. This is also known as tweening, and keyframes are the foundation of animation because without them, the software would not know how to tween or how to move the character. I'm going to quickly demonstrate how to create and edit keyframes in Blender. Now, it's very important to know that keyframing works functionally the same for objects, bones, and you can even keyframe visibility, materials, and several other values. Before we begin, I want you to know that there are 3 keyframe editors. These are the graph editor, the dope sheet, and the timeline. All 3 of these have the ability to manipulate keyframes, and I will reference them here and there. But the timeline is what we'll be showing as the default screen has it at the bottom of the layout workspace. However, we'll go in depth about each of these editors in their own separate videos. The first thing we'll want to know is how to insert keyframes. There are several ways to do this, but it's simple enough. The first way is to simply select something and right-click for a context menu, or right-click directly on the value and see if it has the Insert Keyframe option. If so, that value can be keyframed. Let's take this rotation mode dropdown for example. As you can see, the value will turn yellow, meaning there is a keyframe on your current frame for that value. This will also create a visible keyframe in your dope sheet and timeline at your current frame, marked by these small yellow shapes. They should be yellow circles by default, but are sometimes squares or diamonds depending on your handle type. They are also typically diamonds in the timeline, but we'll get more into this in the dope sheet and timeline videos. For some things, such as objects and bones in the 3D viewport, you'll also see an additional menu pop up when you try to insert keyframes. For example, if we select our cube, you'll see a list of options that looks like this. I typically pick Lock Rot Scale, as it'll insert a keyframe in all 3 transformation channels. But feel free to experiment and choose an option that's most appropriate for your situation. For hotkey users, simply select the object you want to keyframe or hover over the value you want to keyframe and press I as an insert to insert a keyframe in the same way. Another way to insert keyframes is with the auto keyframe feature. Enabling auto keyframe mode will actually automatically record changes and transformations we make to any object in our 3D scene and insert keyframes for us. It will also record changes in values that have been keyframed before. To test this out, I'm going to select a different object. In fact, let's add a monkey to our scene. And to set a keyframe for this monkey object on our current frame with the auto keyframe feature, we can go to our timeline and press this white circle record icon button. Now that auto keyframe is enabled, if we move or transform our monkey in some way in the viewport, you can see a keyframe being automatically generated here in our timeline and dope sheet. Now, you may notice after inserting the first keyframe, transforming our object further doesn't seem to insert new keyframes. But the reality is, it is changing the current keyframe, it's just replacing it. To insert a separate keyframe, we'll want to change our current frame first. So how do we move our current frame to a different position in the timeline? The current frame is indicated by this value here, which you can edit manually like most values in Blender. But a few other ways is to left-click drag the top of the timeline here, or hold Alt and use the scroll wheel. For fine-tuning, you can also press the left and right arrow keys. Anyways, for this, I'm going to just move to frame 20. Once we move to a later point in our timeline, let's set another keyframe by simply transforming our object again. I'm going to move it just a bit to the right. Now that we have more than one keyframe, we can see the automatic interpolation, or tweening process that the software does for us to create animation. Let's drag our timeline back to the beginning and press the play button. For hotkey users, you can press spacebar. Okay, now you can see our monkey is moving. What we're seeing here is the software taking our 2 keyframes and interpolating the transformation between the first location and the second location. This interpolation can be tweaked in the dope sheet or graph editor, but we'll talk about those in their own separate videos. For now, this is our masterpiece. But what if you want to delete keyframes? How do we do that? Well, to delete keyframes, you can simply use the timeline or dope sheet, select the keyframes you want to delete with left click, and press the delete key. Alternatively, you can also navigate to the frame with that keyframe and right click for a context menu. Then select delete keyframe. Quick tip, from the same menu, you can also click clear keyframes to delete all keyframes for that value. It's important to note, however, that the delete keyframes option is not available in the 3D viewport context menu, but you can still go to the object menu, go to animation, and select delete keyframe from that menu. For hotkey users, you can select the object or hover over the value with the keyframe on the current frame and press Alt-I to delete keyframes in the same way. One more thing you'll want to know about keyframes is the ability to change keyframe type. This might sound advanced, but in reality it just means keyframe color. This is used for organization of keyframes that are used for certain purposes. For example, you can mark your extreme pose keyframes by selecting them, right-click in the timeline for a context menu, go to keyframe type, and select extreme. This will give your selected keyframes the extreme pink keyframe color. Other colors include blue, orange, and green. For hotkey users, you can hover over the timeline and press the R key to bring up the keyframe type menu. And those are the fundamentals of keyframes. I hope this gives you insight on how animation works and how to create your own animation in Blender. In the meantime, we'll be going over how to edit and manipulate keyframes in the dope sheet, the timeline, and the graph editor in their separate videos.